All right, we're gonna get started. Hello, good morning, everybody. Welcome to another Green Energy Series webinar. Today's talk will be about Combi heat pumps. My name is Edward Louie, and I'll be your host and speaker for today. So, a little bit about Solar Oregon. Solar Oregon was founded in 1979. It is a member-based nonprofit that grew from grassroots efforts to support clean energy and renewable energy. Um, we support clean and renewable energy through education, outreach, community advocacy work. Um, we also organize a number of solar tours throughout the year. About a month ago, we did a solar winery tour, and you can see a picture of that tour from that tour on the right-hand side. It turns out that many crops grow better in the shade than full sun. Thus, installing solar panels on farmland can provide water savings, significantly reduced energy bills, and better quality crops. The farm we toured this past May even installed batteries because they experienced in the past year a very costly loss of frozen blueberries because they lost power for an extended period of time. And so their freezers couldn't keep a large lot of blueberries frozen, and they didn't want a repeat of that incident in the future. And so they installed these interesting solar panels that are called strackers. And so um, it's a both it's a two-axis tracking solar system. And so the solar panels can follow the sun from morning to evening, regardless of what time of the year it is and the position of the sun. We have another tour coming up in October called the Go Zero Home Tour. Um, and that's a tour of usually a combination of existing construction that's been upgraded so that it's fully electric and solarized. And then sometimes we also have some very interesting new construction homes on tour as well. Um, we also organize solarized campaigns, and these are kind of neighborhood group together efforts to do a group buy on solar panels and inverters, and then also get a contractor to come to that neighborhood and then do like multiple homes at the same time, and then therefore saving on the cost of going solar by reducing the overhead cost associated with going solar. We also do a number of peer-to-peer education events, such as this webinar. So, Solar Oregon, we are a lean and mean nonprofit. We have two paid staff, and then everyone else, including myself, is a volunteer. I wear many hats. I'm both a board member, a volunteer, and then occasionally I speak at Green Energy Series topics, such as this one on Combi heat pumps. You can visit this link if you feel like you want to donate a small amount to our nonprofit. And then you're also encouraged to use the Zoom's question and answer features to ask questions. So a little bit about me. During my day job, I work as a building energy efficiency research engineer at the Pacific Northwest National Laboratory. Pacific Northwest National Laboratory is one of 17 national laboratories spread throughout the country. They're primarily funded by the U.S. Department of Energy, and we also receive funding from a number of other sources that at least at PNL represents about 20 to 25% of our budget. About 75 of it comes from the U.S. Department of Energy. You can also find me on LinkedIn. I'm fairly active on LinkedIn and post frequently. So if you like to keep up with kind of my research and my interests, you can find me on LinkedIn. So a little disclaimer is that the views in this presentation do not necessarily represent the position of Pacific Northwest National Laboratory, the U.S. Department of Energy, or Solar Oregon. Best effort has been made to convey facts and information accurately. However, you're encouraged to do your own research and do your own calculations before making investment decisions. So, on the topic of combi heat pumps, most people have never heard of combi heat pumps. So, we're going to begin by talking about what is it, We're going to talk about the three main types of combi heat pumps. Then we're going to talk about kind of the pros and cons of each of those types. And then we're going to then look at something that's really important in combi heat pumps, which is the water heater tank, and specifically the heat exchanger uh, in the water heater tank. So we're going to talk at length about that. And then as well as the heat exchanger in the air handler is also quite important. So we'll talk at length about that. We'll briefly mention some of the features to look for when looking at different products in the combi heat pump space. We'll look at a non-comprehensive table of products on the market, and then we'll look at and we'll end with some conclusions on the product category of combi heat pumps. So, what is a combi heat pump? Well, combi heat pumps uh, are often called by a variety of names. Not everyone calls it combi heat pumps. Some people call them combination heat pumps. Other people call it an integrated heat pump. Still, other people call it a tri-mode heat pump, and other people call it multi-purpose heat pump. So when you're Googling information about combi heat pumps, you should also, look at these other search terms to see if, you get results that didn't come up from just searching combi or combination heat pump, because the industry has not really settled down on a specific, name to all agree upon. Now, regardless of what you call it, these are heat pumps that serve both domestic hot water and space heating at minimum, using one outdoor unit. So one compressor, one outdoor unit. Some of the combi heat pumps can do space heating, space cooling, and domestic hot water heating. And then some of those that can do all three modes can also do heat recovery, so that when you're doing space cooling and domestic hot water at the same time, then the system can recover some of the waste heat from space cooling. And then the many combi heat pumps also can utilize thermal energy storage. Typically, that is in the form of a tank of water that's fairly large, like 80 or 120 gallons, and meaning that like the outdoor unit can charge up and heat up this tank of water, and then um, the air handler can draw heat from this tank of hot water even when the outdoor unit's not running, and so that there's some decoupling between when heat is being used and then also when it's being generated by the outdoor unit. And typically, the design of these systems, the tank sizing results in a thermal energy storage duration of somewhere in the neighborhood of 30 minutes to maybe an hour or two, depending on how cold or how hot it is outside. Um, these on the right hand side is two examples of combi heat pumps made by two different manufacturers. So Medea makes a Cirq combi heat pump. Some advertising and publications online have a very similar system that called the Atom T Mini VRF. Uh, at the 2025 AHR Expo, which is a very kind of major expo in the world of HVAC, Medea called it the Atom T Mini VRF and showcased basically the same system. So maybe it goes by different names. Harvest Thermal uses a system that utilizes a CO2 heat pump on the outdoor side. And we'll talk about this more, but one of the caveats of a CO2 system is that for now, the CO2 technology in the residential sized outdoor units, they don't do cooling. And so it's a heating only system. Um, Not to say that CO2 systems can't do cooling. I mean, there's many supermarket refrigeration systems that are CO2 based, so they can definitely do cooling. But yeah, the products in the residential heat pumps market hasn't gotten there yet. So there are combi heat pumps kind of fall into three main types. Like I said, there's some CO2 monoblock style outdoor units, and monoblock means that the refrigerant stays in that outdoor unit that stays outside of the home, and then a secondary heat transfer fluid, typically water or water plus some percent glycol mix, is what goes inside the home. And so monoblock outdoor units, they installing them in a home does not require any field-made refrigerant connections. And so there's, in theory, a lot lower chance of refrigerant leaks. In the case of CO2, it's not super important whether it leaks or not, because CO2 has a global warming potential of 1, and then all the other refrigerants are indexed to how many times CO2 its global warming potential is. Um, in the case of refrigerant based monoblock outdoor units, so refrigerant meaning anything else other than CO2, but because it's a non-CO2, typically, always these systems can do heating and cooling. The common refrigerants in the second category is R32, R454B. There used to be outdoor units that are R410A, but R410A is being phased out, and so the R32 and R454B refrigerants are the lower global warming potential replacement refrigerants. Same thing in that third category. Those refrigerant split systems are also R32 or R54B. Now, in Europe, there are some refrigerant monoblock outdoor units in that second category that use propane as a refrigerant. Propane has a much lower global warming potential than R32 and R454B, but propane is highly flammable. And even though propane is used in gas barbecues all the time across the country, and people seem fine using barbecue grills, in the HVAC world, there's great concern about propane. And so, therefore, here in the US market, there's currently no approved use of propane in even monoblock outdoor units. Now, you can get some of them, and then you might be able to get an exception from your authority having jurisdiction to install one under the auspice of, like, pilot testing, pilot program, that type of you know um, allowance. But it is in Europe. The regulations on propane and A3 highly flammable refrigerants is a little bit looser, and so in there are places in Europe where you can install a refrigerant monoblock outdoor unit that uses propane, um, and have it fully actually approved by the authority having jurisdiction. Um, so in terms of examples of these systems, the upper right-hand figure shows a CO2 monoblock system. In the lower right-hand corner shows a refrigerant monoblock system. So a system that pipes water with some percent glycol mixed in it, and then the outdoor unit has, your refrigerant contained only in that outdoor unit, and then the um, outdoor unit has a heat exchanger that takes the heat from the refrigerant and transfers it to that water or water glycol mixture, so that the intermediary working fluid is the water or water glycol fluid that goes inside the home. Now, refrigerant split systems, that third category, can take two forms. One is that it's refrigerant split to all the different components uh, in the inside of the home, or it can be a refrigerant split only to some, like, central hub, and then branching off that central hub, you can have water connections off of that central hub, or cylinder. Different brands call it different things. Um, and so there's two different types, and typically only the type that is refrigerant split to all the indoor components allows heat recovery. So the far left lower figure, that equipment with that typology will typically have heat recovery versus the one in the lower middle. That type of equipment that uses that typology typically will not be able to do heat recovery, even though it's refrigerant split. So something to keep in mind. And so, kind of to recap some of the pros and cons of the different types of combi heat pumps, the CO2 systems have the lowest global warming potential, you'd be using CO2. CO2 also has the advantage of having no flammability risk. But some of the cons of this category is that currently the products on the market can't do cooling. Um, Typically, these systems use just straight water going to the outdoor unit, and the reason is because the CO2 refrigerant has the capability of achieving what's called a very high lift, and so meaning that it can heat water from like let's say 50 degrees to straight up to 130 degrees in one go, and that the CO2 refrigerant cycle is actually the most efficient when you have the incoming water be quite cold, or the whatever that heat transfer fluid is, and it's typically just straight water being quite cold coming in. And so the desire for a CO2 system is not to what's called multi-pass, so circulate the working fluid multiple times, and therefore you end up with warm inlet water coming in back into that outdoor unit. It really kills the efficiency of the CO2 refrigerant cycle if you get warm. Typically warm meaning like anything above 80 Fahrenheit incoming fluid would be really bad for a CO2 monoblock system. So therefore, they do typically do straight water. But one of the downsides of straight water is, well, it freezes, and if you happen to have below freezing weather conditions and a power outage, um, that can be really bad and could damage your CO2 monoblock outdoor unit. Um, Typically, these systems employ some freeze protection methods. It can be it take multiple forms: insulated pipes, a heat trace that goes and wraps around the pipes, water pipes going to the outdoor unit that's on battery backup. And then they can also be installed with freeze protection valves. And so these are special valves that if it detects the temperature is below freezing, you'll actually open up and start to drip water. And so dripping water helps reduce prevents freezing. So oftentimes they're installed with that feature. Um, but one of the cons of CO2 monoblock outdoor units is that there are very few manufacturers of these outdoor units, and then those manufacturers produce very few variations. And so there's, to my knowledge, maybe only two manufacturers make, and each of them only make like one or two models. So there may be only like four different variations of CO2 monoblock outdoor units in existence currently. So that um, if you need like your home to have a 4 tons of heating capacity, the way to achieve it is not to necessarily buy a 4 ton outdoor unit in the CO2 monoblock style. You might have to then buy like two or three, 1.5 ton outdoor units and operate them in parallel in order to get your 4 tons because there are so limited choices in that category. Now, the refrigerant monoblock outdoor units, one of the advantages is that there is a low chance of refrigerant leak because all the refrigerant connections are made in the factory. All those connections have been tested using extremely sensitive robotic, standardized test methods. So then they're made perfectly. Um, because they don't use CO2, but instead use like R32, 454B, or propane. These refrigerants in the standard kind of refrigerant cycle very easily allows heating and cooling ability. So they offer heating and cooling as a function. And then, as I said earlier, Europe already in some areas approves the use of propane, which is an even lower global warming potential than R32 and 454B. Propane only has a global warming potential of 3, but it's highly flammable. So here in the US, it's still not allowed, but in Europe, some parts do allow it. If it starts being allowed here in the US, then I'm sure they would follow kind of the path that Europe is taking, which is that they only allow propane to exist in outdoor unit equipment that is monoblock style, so that no propane refrigerant is being piped inside the home. And so then, like likely that here in the U.S., those monoblock style outdoor units with propane will be the first to be approved. Um, Typically, refrigerant monoblock outdoor units, heat recovery is not possible. Um, in fact, like simultaneous heating and cooling is not even possible. The only way to kind of do simultaneous heating and cooling with a refrigerant monoblock outdoor unit is to have buffer tanks. And so then on the end use side, it's perceived to like you're getting air conditioning and your space heating while you get to enjoy hot water for showers. And it seems like it's happening simultaneously, but no, the outdoor unit is actually, switching between recharging the domestic hot water tank in heat mode and then switching over to cooling mode in order to recharge the chilled water buffer tank on the space cooling side. And that's how it's able to give you the perception that it's able to do both at the same time. But physically, the outdoor unit cannot do heat recovery and cannot do simultaneous heating and cooling. Now, there are some efficiency penalties to having that water glycol intermediate working fluid and the additional heat exchange that needs to happen in order to switch heat transfer fluid. Um, Now, the efficiency penalty of that is quite small generally, but it depends on how well it's installed and the piping layout. And now, if you have a spaghetti of um, water pipes, then you're gonna have a non-trivial amount of efficiency penalty. But that's the same with refrigerant. Also, if you have a spaghetti of refrigerant pipes, then your applied losses is kind of high. Um, Now, generally, refrigerant monoblock outdoor unit type combi heat pumps will have some higher capital cost due to those additional heat exchangers. And later, we'll talk about like the water heater tank and stuff, where there's also some pretty significant capital cost difference in order to have a domestic hot water tank be paired with a refrigerant monoblock outdoor unit. We'll look at that some more. That last row, attention is attention, things that you need to pay attention to when you're working with a contractor to develop a combi system of this typology. So, in the refrigerant monoblock outdoor unit type of equipment, you need to work with your contractor to be emphasize to the contractor it's very important that the domestic hot water tank heat exchanger is large. Do not buy a indirect fire water heater tank that's designed to be used with a gas boiler and hook it up to a heat pump that has a refrigerant monoblock outdoor unit style heat pump. It just will not work well because a gas boiler can generate 190 or 180 degree Fahrenheit water, and refrigerant monoblock outdoor units um, cannot do that. They'll produce 140 degree water, 150 degree water, but for every degree that you're going higher in temperature, your efficiency, you pay an efficiency penalty to those higher temperatures. And so if it's actually better if you can like oversize your heat exchanger in your domestic hot water tank and your air handler and then be able to operate on lower temperature water produced by that heat pump in the outdoor unit. So that's true across the board. The heat exchanger and larger heat exchanger and lower temperature refrigerant, lower temperature water is results in greater efficiency in on the heating side. Same thing on the cooling side with that larger heat exchanger size, you can have warmer temperature water, so you don't have to chill your water as cold in order to get the same amount of air conditioning power. On the refrigerant split systems, They are generally the lowest cost systems because you're operating with the fewest heat exchangers possible in order to make a combi system work. Being direct uh, refrigerant exchange, you get generally very good efficiency. Um, as I said in the previous slide, that there are refrigerant split typologies that allow heat recovery to happen. And then, of course, being a non-CO2 system, heating and cooling is easily achieved with the common refrigerants like R32 and R454B. Now, refrigerant split systems do require field-made refrigerant connections, and so the chance of a refrigerant leak depends on the installation quality. Um, we really encourage people to go with a reputable installer that warranties their work for a very long time. Um, and then it, being a refrigerant split system, you have refrigerant going inside the home. Likely, if it ever gets approved, it will be the last product category to use propane, which is a very good refrigerant, has very good properties, and also low global warming potential, but it's flammable. It's highly flammable. So, convincing the regulators that, hey, if we allow natural gas in the homes and we allow barbecue cylinders in on patio porches, um, why not allow propane as a refrigerant? That's going to take some time to convince. And then things to pay attention to in this category, again, install quality is really important. And then also on the domestic hot water side, the tank heat exchanger design is really important to water domestic hot water heating efficiency. And we'll talk about that some more in the next slide, which is here. So um, when I said that there's some price differentials between if you pick a refrigerant monoblock outdoor unit versus a refrigerant split outdoor unit style combi system. Um, a lot of that cost difference, in addition to being in the outdoor unit, also happens to hit you in the domestic hot water side of the combi system. And it's because it like the heat transfer fluid for a monoblock style system will be typically a water glycol mix, so that in the wintertime there's no chance of freezing. But that you cannot have water or glycol mix into potable water and have that be safe. And so it has to be a indirect fire heat exchange inside the tank where the water glycol mix circulates in a closed loop between the outdoor unit and the inside pipe of the slinky inside the water heater heat exchanger. And you can imagine just looking at the picture that building this heat exchanger and then fitting inside the tank and then welding it so that all the connections between the heat exchanger and the outer cylinder of the tank so that it's 100% waterproof for 15 years, 20 years, whatever the tank life is, um, that it's kind of more challenging than the far right picture where, the heat exchanger is put onto the tank like a jacket and, it's simple enough, a robot can just like boop, wrap the tank and then secure the bolts to keep it secured. So hence why there's a fairly significant price difference between the indirect fire internal heat exchanger domestic hot water tanks and the tanks that receive refrigerant and then the heat from the refrigerant directly exchanges through the tank wall into the domestic hot water inside the water inside the tank. Now, the the world of this type of heat exchanger, the wraparound tank heat exchanger, has only kind of in the recent years become a viable option. In the past, there was a problem with getting enough heat to go into the tank through the heat exchanger wasn't good enough to be able to transfer enough heat through the outer tank shell into the water inside the tank to actually get good domestic hot water heating performance. Um, but that's changed in recent times through many different researchers work on this issue. And one of the challenges to solve is, okay, well, if I take back-to-back baths and drain the water heater tank, then I have cold water near the top of the tank. Okay, so if I put the hot refrigerant gas at the top, it will quickly then be absorbed into the wa cold water that's at the top of the tank and therefore condense from a vapor into a liquid. But what happens if I only take like a short shower and I only have like 10 gallons of cold water at the bottom I need to reheat? Well, if you put the refrigerant at the top and the refrigerant needs to then travel still through all those top paths in order to make it all the way to the bottom, then it takes a long time. And then, there's a bottleneck in the refrigerant flow to the bottom. And then you get very poor heating performance to the bottom of the tank if you only have 10 gallons of, cold water at the bottom of the tank. So some of the latest innovations in these wraparound tank heat exchangers is having these what they're calling orifice baffles in the header of the heat exchanger, and this main pipe that connects kind of all these kind of branches coming off, that's called the header, and the new headers have holes in them called like orifice, and so then when there's hot water up here then and only a little bit of cold and the cold water is kind of at the bottom of the tank, that refrigerant vapor in contact with the hot water will not condense. It will still stay a vapor. And as a vapor, it can go through those holes in the header and kind of bypass all the top refrigerant branches in the heat exchanger and then go straight to where the heat exchange needs to take place. But if you have cold water at the very top of the tank, then what happens is that refrigerant vapor then will condense at the top, but then that liquid will then block the small holes of the orifice. And so then it'll prevent that refrigerant vapor from kind of going straight to the bottom of the tank. So that you're still getting the top to bottom heating effect when the tank is very cold. But then when the tank is only a little bit cold at the bottom, you can, have the efficiency of being able to bypass all the top heat exchanger in order to get the hot gas to directly heat the bottom of the tank. So you get the best of both worlds. Um, and this game-changing design has, really enabled a number of manufacturers to go with this route. Because before this kind of game changer heat exchanger design, what has happened in the past is that manufacturers would go with even in a refrigerant split system, they would pipe the refrigerant into a brazed plate heat exchanger and then have a circulation pump and then a closed loop of water that goes between the brazed plate heat exchanger and this heat exchanger that's internal to the tank, and then deliver the heat from the refrigerant through this kind of convoluted, heat exchanger design that's very expensive. If you think that, the $2,800 tank is expensive, tanks with this design sometimes go as high as 4,000, almost $5,000 for this type of tank. So, this design is quite expensive, and you can imagine that it's not nearly as efficient as necessary to delivering the heat from the refrigerant straight into the water through the tank wall and not needing that secondary heat exchange fluid. And so, if you choose to go with a refrigerant split system, it would be best to just pick a manufacturer that can sell you a system that has a wraparound heat exchanger, a refrigerant to tank heat exchanger, um, rather than get one with this design. This is kind of an older design that may sort of disappear in the next few years. Now, so then that kind of covers the water side. On the air handler side, same thing. Water and glycol generally doesn't squeeze into small pipes as nicely as refrigerant does. And so a if you have a system that uses water or water glycol mix to deliver the heat into the air handler, you will need larger pipes. And so, like for example, for the same size system, same heating and cooling capacity, you would need an air handler with 3/4 inch inlet and outlet versus in this case, on the refrigerant side, the direct equivalent capacity would only need a 3/8 inch and a 5/8 inch pipe in order to deliver that same amount of heating and cooling capacity. So, you have to think about, is your home's how tight is your home in terms of like the area around your air handler? Like, can it handle two 3/4 inch pipes being, snaked through like the crawl space or the attic or the ceiling joists and stuff like that in order to make it to the air handler? Now, I used to think that, well, since there's fewer, hydrocoil um, heat exchangers on the market compared to refrigerant heat exchangers on the market, that hydrocoil or hydronic coil heat exchanger will be much more expensive than refrigerant heat exchangers. It turns out that it's not really not really true. That they may be a little bit more, but it's not as big of a difference as on the domestic hot water heater side. The domestic hot water heater side of the equation is pretty significant, the price difference. Um, Now, interestingly, another thing about hydronic coils is that um, unlike refrigerant heat exchangers, where on the dehumidification performance, you can kind of dial in your dehumidification performance by adjusting, how much superheat is in the heat exchanger, meaning that you can fill the indoor unit heat exchanger with just a little bit of refrigerant, or you can fill it with a lot of refrigerant, or you can fill it with just the right amount. But you can use electronics and software to be able to, in a refrigerant system, adjust that refrigerant fill rate, and that adjusts what percentage of the coil is truly really cold versus kind of not that cold because the refrigerant's already picked up heat from the ambient air and then it's fully vaporized and superheated. Um, with a hydronic coil, there is no phase change, and so the only way you can adjust dehumidification is with water temperature, but you can't fill the coil a different amount. And so, what some hydronic air handler manufacturers have done is that they recommend that in places that have a significantly different heating load versus cooling load, such as um, in the northern states where you get a really big heating load, but then the cooling load's not that bad, but there's still humidity in the summer to manage, that you actually have a air handler with two coils so that in the heating season you can have your chilled water coil be running hot water on top of your hot water coil, and that the two combined will deliver enough heating capacity to the home to stay warm in the coldest days of winter. But then in the summertime, when you need that dehumidification, you can, have the chilled water coil being only the chilled water coil running, and then not overcool the building, but still be able to allow that chilled water coil to stay pretty cold to be able to get dehumidification effects. Um, so that's why there's some manufacturers like the one I'm showing here gives you the choice of, what's uh, chilled water coil to insert and what hot water coil to insert, and that you can kind of like, mix and match in order to uh, meet the heating cooling load of your particular climate zone. That's kind of smart. Now, refrigerant coils, like I said, you can fill a coil with a different amount of refrigerant through software, and then adjust your superheat target and subcool targets in order to have the same effect. Now, on a ductless example, again, price difference. I used to think that the price difference would be between the hydronic coil and the air refrigerant coil would be much more expensive on the hydronic coil side, but turns out, not really. But again, the pipe size is pretty significantly different. For this 12,000 BTU heating to 9,000 BTU cooling example, the hydronic ductless system would need 3/4 inch inlet and outlet for the water connections, versus if you on the refrigerant system you only need 1/4 inch and 3/8 inch pipes. So therefore, like again, snaking 3/4 inch pipes through a stud wall. Like, can you do it? In some houses, the answer is yes. In other homes, it could be kind of difficult. So, something to think about. Now, features to look for in combi heat pumps is how is the combi heat pump system doing defrost? It's a good question to ask because um, now you are combining domestic hot water heating and space conditioning together. So you don't need to use your space conditioning air handler uh, for to grab the heat for defrost anymore. You can grab it from the domestic hot water tank, and then what will happen is like you'll cool down your water in your domestic hot water tank maybe like 2 degrees, but is that noticeable? No. So then like you can get fast defrost without necessarily having a significant amount of time where you notice the defrost happening. So that's really cool. But do all the manufacturers of these products do that? No. So you have to ask like, okay, well, how is the system set up, and then what kind of software logic do they have set up to do the defrost? Another thing is heat recovery. I mentioned that, a number of the refrigerant split systems in Combi can do heat recovery. Um, some people question whether heat recovery is really that beneficial, or is it just like an advertising thing to, differentiate yourself in advertising, but in reality, the energy savings is actually pretty small. And well, it depends on your hot water habits. Like, it's true in the summertime, your cool air conditioning load is really big, and the amount of energy you'd actually need to for heating the kind of warm city water coming in to the home is not that high compared to the amount of air conditioning load. So the amount of hours out of the year when you're actually doing heat recovery is maybe kind of small. But if you take a daydreaming shower, or you sit in your bathtub and you fill it all the way up, then if you got high hot water usage or warm water usage, then yeah, I mean the heat recovery would be beneficial. So it really depends on um, your hot water usage habits, uh, how useful heat recovery is. So there's a point to that argument. But my counterpoint is, okay, well, if the system comes with heat recovery and basically at no additional cost, then it's a nice feature to have. Now, this is a non-comprehensive list of products on the market, but if you're trying to Google and like figure out, as these products become more available in the U.S. market, what to even Google for, then save this slide, screenshot it, print it out, and then, you can continue to keep track of, these different manufacturers, these products, and see if it becomes available in your market. And then, of course, if you find a different maker model that, is in each category, feel free to, add that to the list for your own personal tracking. Um, so uh, this is a good start to the list. Now I do have, I wonder if it'll play some videos kind of from the manufacturers, kind of highlighting, um, hmm, okay, maybe we won't do the video then. All right. And then let's see if we go to the next slide. Oh, okay, there's a slide. Oh, this one seems to work. Okay. So we're gonna Okay, so we're going to pause the video in this area to kind of show you, okay, well, what's going on in these different modes when it comes to combi heat pumps, because this is the unique part of combi heat pumps. Okay, it can do space cooling and water heating at the same time in some systems. Like this one's a refrigerant split system that pipes the refrigerant all the way to each end product. So the refrigerant going all the way to the water heater tank, refrigerant going all the way to, and then it can also do just space heating. And so those are the different modes. Okay, we'll jump to the conclusions. So some of the pros and cons of combi systems is that for a highly efficient space heating and domestic water heating system, being that it uses one compressor and In the case of a refrigerant direct exchange system, you're also having the minimal number of heat exchangers, and so possibly that very likely you'll end up with kind of the lowest cost system for to achieve high efficiency space heating and domestic hot water. Potentially, you'll also get space savings, both on the outdoor side, particularly on the outdoor side, by not having two systems. And then in the in your water heater closet or the area where your water heater tank is placed, by having the heat pump components um, in the outdoor, then you have some vertical space savings. On the near your water heater area, and then combining both domestic hot water and space conditioning together in using one outdoor unit results in some circuit breaker space savings, and that can result in not needing to upgrade your circuit breaker panel in order to convert both space conditioning and domestic hot water heating to heat pump. And so that could be a very significant cost savings by not needing to upgrade your circuit breaker panel. Um, you get high performance heat pump water heating because you're utilizing a powerful outdoor unit for domestic hot water heating. Um, and then in some systems, heat recovery is possible, and so that's a nice feature to have. Some of the cons associated with Combi heat pumps is that currently the U.S. market penetration for Combi heat pumps is pretty much zero. Um, so we're starting off kind of at the grassroots right now in the world of Combi heat pumps, which also means contractors are not familiar with these types of products. And the test and rating standards for domestic hot water and space conditioning, neither of them give credit for heat recovery because they're separate tests, so they never expect a system that combines the two and then can do heat recovery and then provide some test that gives credit for the heat recovery. So if you buy heat recovery, a system that's capable of heat recovery, you're not going to see that benefit reflected in the ratings on both the domestic hot water ratings or the space conditioning ratings. So some upcoming events is that Green Energy Series is taking a break for the month of July. August's topic will be on induction stoves, and that presentation will talk about some interesting induction stove technologies, including dual coil, so-called all metal compatible induction cooktops, battery buffered induction ranges, and also induction tops that offer very precise temperature control, like 5-degree increments, for example, very precise temperature control, and how it achieves that from a technological deep dive. Uh, in June 12th, well, there's a webinar on comparing solar quotes. And then if you are in Medford or you have friends that are in Medford and want to, learn more about solar, you can uh, show them that there's an opportunity to do that on June 24th in person at the Medford Public Library. There's going to be an in-person um, uh, webinar, not webinar, in-person presentation about how to go solar plus storage. And then July 11th through the 13th, Solar Oregon will have a table at the Oregon Country Fair. So it's very popular event. If you're going to the Oregon Country Fair, stop by the Solar Oregon table. Okay, and that might be all I've got. Let's see if, due to the internet glitch, whether we still have anyone with questions. Let's see. Um, I'm having trouble even accessing my Q&A controls. Let's see. This is not good. Okay, let's see. Chat, Q&A. I am not seeing any Q&As. Uh, okay. Well, if there are no questions, then you guys all have a great rest of your Saturday, and I hope to catch you on one of the webinars, either the June 12th webinar. I may be attending this Oregon Country Fair in July, so I might see you there. If I don't see you in June or July, then I will definitely see you and look forward to seeing you on August's Greenery series on induction stoves. With that, we'll bring this webinar to a close, and you guys all have a great rest of your Saturday. Take care, everybody.